All right. Hello, welcome back. These will be our first notes of the new Eastern course. And hopefully you guys will feel real comfortable on this. In the past, we haven't really done, we've done kind of let students do it on their own because a lot of this stuff is a review. But in this time where we don't know exactly what everyone learned over the past few, last semester, we want to make sure that you guys are completely prepared. So we're going to go through this maybe a little quicker, but we're going to go through this regardless. So Pythagorean theorem and its converse. So everyone, like when you guys graduate and you get old like me, the only thing you're going to remember from high school math is the Pythagorean theorem and possibly the quadratic formula of some sort, right? So here's the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So that is the right triangle shown, c squared equals a squared plus b squared. And I actually prefer to write it like this, c squared equals a squared plus b squared, as opposed to the other way around, because then you can use this kind of way of writing it as a way of kind of checking your answers. I mean, again, it doesn't really matter the order you put it in, but if you're trying to confirm that something is in fact a right triangle, it's nicer to do it this way. So that's what I mean here, the converse of the Pythagorean theorem. In a triangle, if the square of the lengths of one side equals the sum of the squares of the lengths of the other two sides, the triangle is a right triangle. The 90-degree angle is opposite the longest side. And sometimes this is what students forget when they're doing this check, is they just plug in numbers into the Pythagorean theorem, but the biggest thing is you have to make sure that the biggest side, or the longest length, is going to be that c term, or the c squared term when you substitute it in. All right. So now the first question is, the lengths of the legs of a right triangle are given. Find the hypotenuse. So they're telling you that these are the legs, right? So that, they're giving it to you right now, a and b, a and b. So 5 squared plus 12 squared equals c squared. I'll go a little faster here. 9 is equal to c squared. C is equal to 13. So that's the length of the hypotenuse. 14 squared plus 48 squared is equal to c squared. 2500 is equal to c squared. C is equal to 50. All right, so no issues there. But now, this is the kind of question that sometimes students get in trouble with. So you're trying to determine if it's a right triangle. And the way we got to do this now is set it up by putting it into the formula correctly. So the longest side is always going to be that c term. And if it's true, that means it's going to satisfy the Pythagorean theorem. So let's see. Does 6 squared equal 4 squared plus 5 squared? And does 36 equal 16 plus 25? And we know it does not. So this is not a right triangle. Okay, it's my little shorthand to save time here. Okay, so little right angle, right triangle. Over here, does 26 squared equal 10 squared plus 24 squared? So in other words, does 676 equal 100 plus 576? And the answer is yes, it does. So these would be the legs of a right triangle, where 26 is the hypotenuse and 10 and 24 are the legs. Okay, so these are formulas, and obviously during this time of COVID, you guys have you guys are gonna have access to this. So it's not like you have to memorize these, although you know that area of a rectangle or any kind of or quadrilateral is length times width. Perimeter is 2L plus 2W. You know that for a triangle, the area is 1/2 base times height. The formula for the perimeter, if you're doing this, these are perimeter formulas. This is area. If you're doing the perimeter formula, you'd have to give it other names. So let's call this A and let's call this C. So the perimeter of a triangle would just be adding all three sides. And I know you guys know that. Okay. Over here, circumference and area of a circle, pi r squared and 2 pi r, or pi times diameter. Again, sometimes students confuse these two. So just think about it like this. If it's squared, it has to be area, because area is in square units. So for example, meters squared, miles squared, kilometers squared, and circumference is just in regular units, so like miles, meters, kilometers. right? So it's not squared. Therefore, the radius has to be squared because all the units are squared. Over here, three-dimensional objects, the volume is length times width times height. This is for a rectangular prism. Okay, and over here, surface area, 2 times the length times the height plus 2 times the width times the height plus 2 times the length times the width. There's other formulas I'm sure you guys learned, but this is the one that's pretty basic. Volume of a sphere, 4/3 pi r cubed, surface area, 4 pi r squared, and for a cylinder, pi r squared times the height, and 2 pi r squared plus 2 pi r h. So let's go ahead and use these. So example 2, find the volume and surface area of a sphere with a radius of 4 inches in terms of pi. This is going to be really important, this in terms of pi thing, especially for Math Excel, because that means the exact answer. So I know that we're kind of used to using our calculators for everything, but in this case, you could use it to do 4/3 times 4 cubed, but don't put the pi in the calculator, otherwise it won't be exact. So the way you're going to enter it, so volume is 4/3 pi r cubed. So the only thing you would put in the calculator would be this and this. Don't put pi in there because otherwise it won't be exact. All right, and this is going to give you 4/3 256 pi over 3. That's what it means in terms of pi. If you're to round it, you're going to round it to 268.08 inches cubed. Now for surface area, again, just go up there, and if you don't remember it, you can use the formula. Okay, not a big deal. So for surface area, it's 4 pi r squared, or 4 pi 4 squared. And again, the only things you're putting in your calculator are these. And so the surface area is 64 pi. That's the exact answer in terms of pi. If you were to put in your calculator completely, which we didn't ask you to, but if you did, it would be 201.06 inches squared. So notice surface area is squared, volume is cubed. Find the volume and surface area of a closed rectangular prism with a length of 8, width of 4, height of 7. I mean, you could draw it out, and I always like to draw out any kind of geometry problems just to get some perspective. So the length is 8, the width is 4, and the height is 7. And for rectangular prisms, it doesn't really matter really where you put them because the formulas are so easy to use. So the volume is just 8 times 4 times 7, which is 224 feet cubed. And the surface area, well, again, if you don't remember, that's okay. Go up there, use the formula. 2LH plus 2WH plus 2LW. So 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height. And you're going to get 232 feet squared. All right. So again, using the formulas, pretty good. I love these kind of questions, and I'm going to ask you guys to pause it, and you're going to find the area of just the shaded regions here. Okay. So I love the creativity that students use when they do these problems. So pause it, but I'm going to go ahead and do this. So the way I like to look at it is, find the area of the entire rectangle. So I like to draw out a plan, rectangle minus triangle. There's a triangle here that we could kind of subtract out. So the rectangle is going to be, area of the rectangle is going to be 7 times 6, or sorry, 7 times 5, which is 35. The area of the triangle is, well, here would be the height, so that's 1/2. The height is 5, and from here to here it's 3, which means from here to here it's 4. So the area of the triangle is 10, and then the area of the shaded region is the difference of those, 35 minus 10, which is 25 meters squared. Okay, over here, a couple ways of thinking about it. You could do the same thing, the rectangle minus 2 circles, because you have one whole circle here, and then you have 2 halves, which makes it another whole. So the rectangle if you look at it, this is 3, this is 3, this is 3, this is 3. So the width of the rectangle is 3 plus 3 plus 3 plus 3, and the height of the rectangle is 3 plus 3. So the area of the rectangle, go to a different color here. So the area of the rectangle is 6 times 12, which is 72, and the area of the two circles, okay, that's 2 times pi r squared. So pi 3 squared, which is 9 pi 18 pi. So now, the exact answer, if we're going to do exact, is actually 72 minus 18 pi. Right? That's the exact answer. But the approximation is 15.45 units squared. Okay, how many feet does a wheel with a diameter of 20 inches travel for 3 revolutions? Again, I love this kind of problem because it makes you think. So try it on your own, hit pause, but I'm going to continue for the sake of time here. So now let's think about this. So we're drawing a wheel here, and we want to know what's the diameter of 20 inches, how many feet does it travel? So as you're rolling it, 3 revolutions, how many times does it roll over itself? 3 times. Well, let's first get an idea up here. So the diameter is 20, so that means from here to here it's 20. And really, this comes down to be a circumference problem. So the circumference is equal to 2 pi r, but remember, it's also just pi times diameter. And you're already given the diameter, so you don't need to break it up. So this is just 20 pi. And 20, how many times does it travel with 3 revolutions? So it's just basically 3 times the diameter, which is 60 pi. And most students would just stop right there. They'd be like, oh, this is easy, I got it. However, you got to read. It says how many feet does it travel? And you're given this in inches. So this is 60 pi inches. So to figure out how many feet it travels, we have to divide by 12. So 60 pi inches divided by 12 to get to the feet is 5 pi inches, or 5 pi feet, which is about 15.7 feet. Not feet squared, just feet, because it's circumference. Okay, this is another cool problem. This is actually our last problem. So a circular swimming pool has 40 feet in diameter, is enclosed by a wooden deck that is 6 feet wide. So this is the wooden deck here. So this is 6 feet wide. What is the area of the deck? So again, it's always a good idea to come up with a plan. So hopefully you guys could see that we're actually dealing with 2 circles. We have a giant circle here, okay, and then we have another smaller circle here. So we can find the area of the pool, or area total, minus the area of the pool, and that would give us the area of the deck. So let's start filling in what we know. So the circular swimming pool has a diameter of 40 feet. Okay, so that means from here to here, it's 40, which means that the radius is 20. So the area of the pool is pi times 20 squared, which is 400 pi. The area total, now this is where you got to be, a little careful and understand what's going on. So 6 and 6 and 40, so the entire diameter of the whole area is 52, but just the radius, which is what we want, is 26. So the area total is pi times 26 squared, which is 676 pi. And now to find the area of just the deck, I have to subtract these two. So I'm basically taking out that donut hole there in the middle. So it's area of the deck is 676 pi minus 400 pi, which is 276 pi, or about 867.08 feet squared. Okay. Now, again, we got to make sure we read that we found the area of the deck, and that's what this is. But now it also asks for how much fence is required to enclose the deck. So now we're just looking at, again, you don't not going to enclose the deck and the pool. They just basically want this on the outside here. Okay, so we have to use the circumference. So that's just 2 times pi times 26, which is 52 pi, or about 163.36 feet. When you go to the hardware store, you're not going to say, I want 52 pi inches of fencing. They'll look at you funny. So you got to make sure you can translate to get the approximation. All right, this might have been our shortest notes ever. We will see you in class. Bye.